calculate for 3 subnet ID, and the given class full LAN ID is now belongs to class B. Given class full LAN ID is 172.16.0.0/16. Also calculate, also find out network ID, broadcast ID, first valid IP, last valid IP, and valid IP range for each subnet. In case of class C, we have divided that number in 3 subnet ID. In case of class B, again we are calculating for 3 subnet IDs. We want to see what is the difference if we are divide the class C NID into 3 parts, and if we are divide the class B NID into 3 parts. What will be the difference? Solution. In step number 1, we will write the mask. The given mask is 255.255.0.0, and that is known as default mask. Don't call it subnet mask, default mask. Step number 2, in place of 255, we can write 8 bits binary number, and in place of 0 we can write 8 zeros. In step number 2, from left to right, 16 bits are 1, and all 1 bits belongs to the network. 16 bits belongs to the network, and the 16 bits zeros belongs to the host. By default, in case of the class B, 16 bits network to the network, that is represented by the 1, and the 16 bit belongs to the host, represented by the 0. In step number 3, we will apply the formula for number of subnet, and the formula is x equal to 2 to the power n. And in case of the class C, the value of n we can take from 0 to 6, while in case of class B, the value of n we can take 0, 1, 2, and we can take up to the 14, 1, 4. Because by default, class B have how many bits? 16 bits, and the maximum bit of the network in any IP address can be 30, and 16 bits plus 14 bit equal to the 30. 6 bit from the last 4th octet and the 8 bit from the 3rd octet. 8 plus 6 is 14. Our requirement is how much? 3 subnet. We want to get the 3 subnet, and let's say we are putting the value of n is 0 here. We are not getting our answer. We are getting 2 equal to 0 equal to the 1. We are not getting our requirement here. Now apply the value of n equal to 1. Our answer is 2, but our requirement is not fulfilled. On n equal to 1, apply the value of n equal to 2. We are getting the output 4. X is equal to 4, and our requirement is 3. Our requirement is coming under the 4. Now we will not turn on any bit. Our requirement is 3, and we are getting the answer 2 to the power n is equal to 4. Our requirement is coming under the 4. The value of x either greater than 3 or equal to 3. This value is greater than 3. Do not increase more n values here. In case of step 4, we will write first 16 bits of the network, that is predefined, we cannot manipulate in case of subnetting, and we are getting our result, our requirement number of subnet at n equal to 2. That's why in case of third octet, we will turn on 2 bits from the third octet, and the rest of the bits of the third octet will be 0, and fourth octet bits will be 0. So in case of class B, subnetting will affect the third octet, while in case of the class C, subnetting will affect the fourth octet. In step number 4, we have 16 bits belongs to the network, predefined in the iOS, and 2 bit belongs to sub network bits, and the rest of the bits 6 plus 8 equal to 16. Now the remaining host bits is 14, 8 and 6, and the default host bits was 16. We have turned on 2 bits in step number 4 for the sub network bits. Now the total bits of the network in this is 16 plus 2, 18.